so we're going to go to the B part. Calculate the reaction rate constant K. Now to do this, we're going to use the rate law that we calculate, and we're going to choose and use one of the data sets. It doesn't matter which one. Okay, it doesn't matter, you're just going to pick one of them. Alright, so we know that our rate law, so our rate is equal to K times the concentration of N2O5 to the second power. So let's go ahead and we can put in, I'm going to use, let's see, which one did I use? I used the first data set. So I'm going to use this guy right here. So I have a reaction rate of 0.085 and a concentration of 0.10. So I'm going to put that into my rate law. So I have 0.085 equals K to the 0.10 squared. So I got to get K by itself. So K equals 0.085. And this would be, let's put in units because we're going to have to use them to calculate. This is moles dot liters to the minus 1 dot second to the minus 1 all over 0.10, and this would be moles per liter. And then we end up squaring this. When we do the math, we end up with 8.5. Now, we got to be careful with units. Alright, so these units become moles squared over liter squared. Or we could write this moles squared dot liters to the minus 1 minus 2. Okay, so we could do this. All right, and then we have to cancel things out. All right, so we got a mole and a mole squared. Okay, we got a liters to the minus 1, and we have a liters to the minus 2, and we got per second. So when we do this, we end up with, we have a mole minus 1 left. The liters actually would go on top, so this would be liter dot mole to the minus 1 dot s to the minus 1. All right, so for our first order reactions, for our second order reactions, our units are going to be liter dot mole minus 1 second minus 1. Okay. So what's important here is that you're really careful with units. Okay, so our units of the rate constant will depend on the order of the reaction. Okay, so these will change. All right, so there's no specific order, or there's no specific unit for every single rate constant. These units change, and that's important. Alright, let's do one more and then I think we'll call it a day. So let's say that we have gas A decomposes into gas B. So A gas turns into B gas. Using the experimental data, determine the order and calculate the rate constant. So I have to give you some data. Right, so we're going to need the concentration of A in moles per liter and the reaction rate. And that's in moles dot liters minus 1 dot second minus 1. So 1.50, we get a rate of 0.320. 3.00, we get 0.640. And then 4.50, we get 0.960. Alright, so the first thing we have to do is we're going to figure out the order and write our rate law. Alright, so the reaction rate, okay, so we're going to use two data sets, and again, I'm going to pick the top two. Okay, so I'm going to data set 1. My reaction rate will equal some constant K times the concentration of A to some order M. Right, so our reaction rate is 0.320 equals K times the concentration of A to some M. No, not the concentration of A. We know the concentration is 1.50, sorry, 1.50 to some order M. My bad. Data set 2. So our reaction rate is going to equal reaction rate 2 is equal to K times the concentration of A to some sort of M. And we're going to use our second data set. So we end up with 0.640 equal to K times 3.00 to M. Right, now we divide, so we're going to take data set 2 divided by data set 1, so we go 0.640 equals K times 3.00 to the M divided by 0.320 equals K times 1.50 to the M. Then we cross off our K's, we divide, this gets 2. We do this math and we get 2 to the M. Alright, when we solve that, M equals 1. So this is a first order reaction. So now we can write our rate law. So our rate law rate equals some constant K times the concentration of A to the first. Now that we have the rate law, now we can calculate K. And we're going to use the rate law. And we're just going to choose a data set. It doesn't matter which one we're going to use. And I'm going to pick the top one because it's on top. Okay, so we'll use our rate law. Our rate for the first one was 0.320. equals K times 1.50 to the first. We're going to bring this over here, and I'm going to bring our units in. All right, so actually bring this over here. So K is equal to 0.320 mole dot liter minus 1 divided by 1.50 moles dot liter minus 1 dot second minus 1. Right, so now this time we're not squaring because it's only to the first, so it changes this bottom unit, which is going to change our overall unit. So when we do the math, K equals 0.213. Right, so our moles cancel out, our liters cancel out, and all that's left is per second. So this is seconds to the minus 1, and that would be our K. Okay, so we're going to stop there, and we will continue on with rate law in the next class. All right, so have a good afternoon, and we will see you next class.